Experiences are what people love the most about travel. That's why they love Viator. They have over 300,000 bookable experiences and something for everyone. Plus, their travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. Download the Viator app now and use code Viator10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on the Space Nuts podcast, episode 100 and something, 48. I think. And we're very, very excited today because there's been a huge announcement that we're going to be discussing, and that is, well, it's probably not a secret anymore, the first photograph of a black hole. First time humans have seen a black hole in the flesh. And we're very excited about that. Fred is looking fairly zombified because he's been up half the night. Listening in on the press conference. So we'll talk about that. Also, confirmation that there is methane on Mars, and we don't think it's Martian cattle. So what could it be? And we've got a question from James in Maine, who describes himself as an astrophysicist hobbyist. I'm more interested in finding out about that. But the question is of dark matter. He's got a bit of an idea, which we will discuss as well. So, hello, Fred. How are you? You're looking.
I'm very well, thanks, Andrew.
You're looking
very
well, wide awake.
Well, yes. The parts of me are awake, but most of me isn't.
Yeah, I'm a bit
it was
the
a
same
late
for
night.
a very different reason. We've switched back to Eastern Standard Time here.
Yeah, right.
So, as I said on my radio show the other day, switching out of daylight saving into standard time is the closest you get to jet lag without moving. And that's, I've been waking up at 2 and 3 in the morning and not being able to go back to sleep. It's ridiculous because it's only a 1 hour shift, but it still knocks you around going backwards.
Sadly, I'm going to, tomorrow I will have a real dose of jet lag.
I'm sure you will. But let's get to the crux of the matter. This exciting news that's been announced overnight, our time, that the Event Horizon Telescope has indeed shown us a black hole for the first time in the history of history. I'm not overstating it.
That must be tautology, that, I think.
I don't know.
You're absolutely right. And you and I have talked about this, this forthcoming event for a long time because we've been spruiking the Event Horizon Telescope for some years. And just to remind everybody, what that is a network of 8. It's actually 8 sets of radio telescopes, not just 8 radio telescopes, around effectively the Western Hemisphere of the Earth. And they were linked together in such a way that they can see detail on a scale that is just unbelievable. For our US listeners, if you were watching from Washington, D.C. with this telescope, you will be able to read the date on a coin held up in Los Angeles. So it's that kind of resolution. Likewise, you could do the same sort of thing with, if you imagine yourself in Sydney, reading a newspaper in Perth over somebody's shoulder, as Alan Duffy said this morning.
However, I would challenge anyone to be able to read what's on a $2 coin in Australia at the moment. They are getting so small with everything they're putting on them. It's ridiculous. So I need that telescope. When
you probably need it anyway. That's right. Yeah. So, but the big surprise, Andrew, is what we didn't see, because I think I was not alone. I attended the media conference by live streaming. I wasn't there, but watched it all on the interweb. I think most people in that audience were surprised that what we weren't seeing was an image of the supermassive black hole at the center of our own galaxy, because that's the nearest one.
Yeah, well, I automatically thought that's the one we would be looking at.
Yeah, me too. But we had hints, I guess, earlier in the week when the announcement was made that there's going to be a major media announcement from the EHT, the Event Horizon Telescope. We had hints in that they revealed then, and this might have been public knowledge before, but I didn't know it, that another galaxy besides our own was being observed. A galaxy far away, 55 million light years away. It's called M87. And the M stands for Messier. Messier was a French astronomer who catalogued fuzzy objects at the end of the 18th century because they got in the way of his comet hunting. So we now have lots of objects in space which start with an M, and this one's M87 for Messier 87. So this is a galaxy with one of the biggest known supermassive black holes at its core. It's actually about 6.5 billion times the mass of the sun. The one at the center of our galaxy is 1,000th of that size. It's about a 4 million solar mass black hole, which by solar mass black hole standards is fairly modest. So ours is much nearer, but it's much smaller. So they've gone for the big one first, and that that was a surprise. The surprise was when the image was revealed of the M87 black hole shadow, in a sense, because what we saw was a blobby image, and when you're imaging something that small, 55 million light years away, you're not going to expect much more than a few blobs, like a kind of badly made donut.
It looks like an orange-flavoured donut in real terms, which I think would be disgusting. But I suppose it's probably cruel to say because of all the effort that's gone into this, but it's a pretty underwhelming image in the scheme of things. But it's an image nonetheless. We've got a picture. It's actually the sort of picture I take as a stock standard myself. That's
quality. When you're taking something right in front of you, not on the other side of the universe. 55
metres away.
Yeah, that's right. So, yes, you're right. And I was hoping we'd rule the word underwhelming out of this podcast episode.
Oh, I'll take the heat for that one.
But you're right. It's blurry, and that's what you expect. But it does show what we expected to see. And that was really the highlight of, I guess, the press conference yesterday. The project director, Shep Doleman, somebody asked, did you have a party when you saw the image? And he said, no. He said, we were all really surprised that the image looked exactly like what we expected it to look like.
Well, yeah, because so many times when you anticipate a new discovery, you are often shocked by how far off you were with the information you anticipated. In this case, that didn't happen at all.
No, that's right. Look, there will be new things learned from this, though. So, yes, you're right. It's an orange donut, to give it the flavour of choice. They may not have factored that into the research, but I'll leave you to tell them that. The orange donut has a bright patch on one side. Actually, on the lower half is brighter than the upper half. In fact, if you look at it half closed, it looks like a one-eyed person with a big smile on their face. It's really, that comes about because the material in that lower half of the image is brighter because it's coming towards us. These things are rotating at almost the speed of light. So it does funny things to the radiation. Of course, these are radio waves that we're seeing, not light, but they're photons nevertheless. If we had a visible light telescope sensitive enough, we could probably see it in visible light, but it's very bright in the radio. And of course, the dusty parts of galaxies are transparent to radio waves. That's the key thing for using radio telescopes. So the picture essentially shows, as I said, it's a donut. It's black on the outside and black on the inside. But the reason why it's black on the inside is different from why it's black on the outside.
Oh, yes. Because there's a hole.
There's a hole there. That's right. So what we're seeing is not the event horizon itself. The event horizon is the point of no return around a black hole. It's the bit where you lose all hope because you're never going to get out of it. This is not the event horizon itself, though. This is a kind of silhouette of the event horizon because all this material is sweeping around the black hole in this enormous gravitational field. And that includes the light as well. So the photons, as well as everything else, are whizzing around the black hole. And the effect of that is that the light that we can see is photons of light, or radio photons as they are, that have just managed not to be swept up by the black hole. Their trajectory is, it's meant that they've skimmed the edge of the event horizon, but then they've escaped and they've whizzed off. And 55 million years later, they land in this suite of telescopes in the Western Hemisphere. So it is the nearest thing we've got to a portrait. Apparently, and I haven't checked the calculations of this. I've got the papers, the research papers, but I've not had time to read them yet properly. But the hole that we can see, the silhouette of the event horizon, I think is 2.5 times bigger than the event horizon itself. So it's like a shadow being cast on a wall almost that becomes bigger than the object that's casting the shadow if you've got the right kind of light source. So fantastic stuff. What happens to the other black hole, though, Sagittarius A, the one we all thought we were going to see images of? And the first question...
Surely they're going to have a crack at that.
Yeah, the first question in the press release was... the media conference, when they opened it up to questions, the first one was, so... when are you going to show us Sagittarius A star, which is the radio name of the black hole at the centre of our galaxy? And the bottom line, the answer was, well, we're working on it still. We're still working.
Yeah, they've got to get around all the dust and stuff. That's why radio telescopes work better in these circumstances.
Yes, indeed.
I was blown away by the amount of data they collected in this project.
Right.
I mean, good grief.
It was 5 petabytes. And I loved the comparison. One of the scientists in the media conference last night put it into really good terms for me, because this is stuff I listen to all the time. How long's worth of MP3 recordings do you think it is? Well, I can tell you on my iPod, I've got about a month and a half solid listening if I wanted to sit down.
If you played everything back to back.
Yeah, back to back, that's right. Whereas this amount of data that they've got from these telescopes will keep you going for 5,000 years.
Gosh,
so that's
just
all right.
Unbelievable. I mean, maybe the image wasn't surprising, but the amount of data was.
I had a look.
Good thing they weren't using the NBN.
The copy of the image that I've got, now let's just see if I can find it. This is the final image. It's sitting on my computer. That is, hang on, where is it? Here it is. It's 11 kilobytes.
So that's taken 5,000 years worth of MP3 data and rammed it down into a small...
To grind it down.
Yeah.
You see, that's why we call it data reduction, which we do. I've spent a lot of my life, not so much these days, but reducing data. You get data from a telescope and then you reduce it. And I always think of the reduction as turning it into something useful, but the word is well chosen, especially when you get 5 petabytes down to, 11 kilobytes.
Yes.
It's pretty good. Good.
This image has just gone berserk all over the place, popping up everywhere. People are looking at it and going, And I guess the remaining question is, are we ever likely to be able to get a clearer image?
Well, I'm sure we will. because, in fact, this was flagged in the media conference that, the next thing is to expand the project with more telescopes. So your Event Horizon Telescope fills in the gaps. You've only got 8. It's not quite only 8 data points on this Earth-sized radio dish, but it's that kind of thing. And the more telescopes you can put in, the more detail you'll fill in with the images. Plus, they're going to go to higher frequencies. And what that does is gives you better resolution. So you see more detail if you can observe this thing at higher frequencies. So there is stuff to come, which I think is really exciting. May I just make one more comment about the media conference, though, Andrew? And
Sure.
that is that the project director, Shep Doleman, it's a big collaboration, and he paid tribute to the many, many scientists involved. But he had a special praise for the early career researchers who carried out a lot of the drudgery there. That's really nice when people do that. That they actually cover it's people who are the postdocs and the PhD students who are very small cogs in a big gearbox, but they do a fantastic job.
Yes, indeed. And I imagine that they will be able to study this data and this image and learn so very much about black holes in time to come. Why else would you bother?
Yeah, that's right.
It's all a learning experience. It's all about knowledge. So, they should be congratulated. It's been a fantastic project. And we will hear more about it, I do not doubt. You're listening to Space Nuts with Fred Watson and Andrew Dunkley. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and skiing with a go.
Space Nuts.
Now, Fred, to another mystery of our solar system, and no less exciting in many respects, and that is that it seems to have been confirmed that there are spikes of methane on Mars or in the Martian atmosphere, which we have spoken about once or twice, and I think it even came up in our last episode, just off the cuff. The mystery of this is finding the source.
Indeed, that's right. So, these methane spikes, you and I have definitely spoken about them before. They are fascinating because it's a story that's been hanging around for well, best part of 10 years, I think. Why is methane interesting? Because methane in an atmosphere, certainly like the atmosphere of Mars, is dissociated by sunlight into its component atoms and disappears. So if you've got methane, you've got a source of it somewhere. On Earth, the main source of methane is biological activity. And so, that's why everybody gets very excited about it. So there have been several reports of methane. In fact, I think I'm right in saying that it was detected initially by Earth-based telescopes. There are, if you're looking in the millimeter wavelength range of radio astronomy, the kind of stuff that ALMA does, the Atacama Large Millimeter Array, which, by the way, was one of the component telescopes of the Event Horizon Telescope. But if you're looking in that wavelength region, then you can detect very small quantities of a compound. I was going to say an element, but of course it's a compound in an atmosphere. And so I think that earthly detections have been made. But there are many instruments on and around Mars which are also up for the job of detecting methane. In particular, Curiosity, the rover that is currently the only remaining active rover on the surface of Mars. There is another active machine on the surface of Mars, but that's not a roving one. The rover is the only one, Curiosity. That is equipped with detectors for methane, and indeed they've detected spikes of methane. By spikes, I mean it's suddenly there and then suddenly it's not. So it's as though, as it's trundled across the Martian surface, there's been a whiff of methane that it's sensed, and the recorder has registered that, and then it's gone away again. Now there are two other spacecraft which are equipped with methane sensing equipment, and one is they're both ESA, European Space Agency spacecraft. One is Mars Express, which has been orbiting Mars now for it's probably 15 years or so. It's quite a long time. That has also detected methane, but just let me mention the other one, which is another ESA spacecraft. You and I have spoken about it before because I think it went into orbit last year or the year before. It is part of ESA's ExoMars project, which is a two-pronged project. One is an orbiter, the other is a lander, which will, I think, fly next year. ExoMars, looking for life. But the thing that's in orbit at the moment is called the Trace Gas Orbiter, and that tells you everything you want to know. It's in orbit and it's looking for trace detections of gas, and methane, of course, is what everybody's interested in. So, okay, Curiosity. I think it was the 15th of June 2013, detected a methane spike. So suddenly there was this, waft of methane went past the Curiosity rover as it was on Mars. And the reason why this is hitting the headlines now is that data analysis and all the rest of it shows that the day after that, on the 16th of June 2013, Mars Express also detected a methane spike from above the atmosphere. So I think it was looking kind of in the right direction.
Yeah. So two independent sources.
Well, two independent measurements, possibly from the same source. They looked. They thought the location of the methane source was about 500 kilometers to the east of Gale Crater, which is where Curiosity is trundling around. So it's possible that source, with prevailing winds going from east to west, which sounds a bit wonky to me, but this is Mars we're talking about, yes. Not the Earth. There are no oceans on Mars, and of course that's what makes all the difference. But maybe the two have the same source because the methane spikes are so close together in time. However, there's a contradictory result which has also been published within the last week or two, which comes from the Trace Gas Orbiter, the thing that's sent there to actually look for methane around Mars. Now, that clearly wasn't in orbit back in 2013. It's more recent than that. But so far, they haven't found any. So that's the surprise, that we would have expected that this spacecraft, which is designed especially to look for these interesting gases in the Martian atmosphere, have not yet found it. And yet there is, pretty solid evidence from other sources that there is methane there. So what is it? What's going on? Are there instrumental issues here? Is it a calibration issue? Has something gone wrong with one of the instruments on?
They left the lens cap on.
You don't need a lens cap for methane. You should know that.
Yeah, I do.
No, but I think this is one of the things that will probably be resolved. I'm sure we will find suddenly that I don't think it's a lens cap issue or, it's equivalent in the radio frequency spectrum. I suspect it's more about the fact that perhaps we've just been out of luck in terms of methane oozing up in the time that ExoMars Orbiter has been there.
Yeah.
I think the thinking, though, it seems to be very much that this might well be of volcanic origin rather than biological origin. That, I think, is coming out a little bit more strongly in the reports that we're reading from the European Space Agency. So maybe it is volcanic. We will hopefully eventually find out, because I think if I remember rightly, the Trace Gas Orbiter has the wherewithal to do isotopic analysis, and different isotopes of these atoms have different origins. And if you can find out what isotope you're talking about, then you might be able to say, well, that only comes out of living organisms, or it only comes out of volcanoes. Oh. So it's still a watch this space, I'm afraid.
Yeah, I mean, they've sort of demonstrated in one of the articles all the possibilities, and one is biological, another one is a chemical reaction. There seems to be, they're the two most likely. We know that tectonically speaking, Mars is pretty well just a rock, but something's going on up there.
Yeah, indeed. So, well, it certainly has been going on in the past.
Well, could it be the last gasps of a near-dead world?
I think that's probably what the planetary scientists think it is. As you say, the last gasps of, maybe the last vestiges of plate tectonics that perhaps shut down on Mars 3 billion years ago, or something like that.
Yeah. We will hopefully learn more in the not-too-distant future about methane on Mars. You're listening to Space Nuts. Andrew Dunkley here with, of course, Professor Fred Watson.
3, 2, 1.
Space Nuts.
Now, Fred, we're going to answer one question today, simply because we burnt the clock on the black hole. This one comes from James Lancaster in Maine, and he describes himself as an astrophysicist hobbyist. That's really exciting. You're going to have to email me, James, and explain it again. I'd like to know what that entails. But he says, thank you, gentlemen, for producing my favourite podcast. It's ours too, strangely enough, James. It's what I listen to when I escape my busy life. Here is my question. We all know the massive stars, black holes, planets, etc. can be inferred by observing their orbits. We also know that objects on the periphery of galaxies are travelling too fast to be explained by the observable mass of those galaxies. Where does it all break down? When do we think, or when do we need to think about dark matter to explain the objects orbiting the galactic centre? That's a deep question.
It's a great question, It's a great question, James. Just talking to James for a minute. But I was going to say it's a great question, Andrew, too.
I'm glad I asked it.
Yes, I'm glad you asked it for James, too.
James.
I think I'm very sympathetic to anybody who's an astrophysicist hobbyist, because that's what I am too.
Yeah.
But somehow I've managed to get paid for it, which just is extraordinary, really. James, I think, since he has the letters MD after his name, is a much more useful a much more useful person than an astrophysicist will be. So it's great to hear from you, James, and it's a great question. Let me try and paint a picture. I'm going to draw a graph in your imagination. Here's a graph of with two axes. The horizontal one is the increasing distance from the center of a galaxy. So you start off with 0, which is right in the middle of the galaxy where there's a supermassive black hole. And then you go out in distance along the horizontal axis, going to the right, out in thousands and eventually hundreds of thousands of light years. And then on the vertical axis, the one that points upwards, you have rotation speed. This is what we call a rotation curve, because it's showing how the rotation of a galaxy changes as you move outwards. So what you would expect, if what's in a galaxy is all you can see, what you'd expect would be the rotation speed. It's very small exactly in the middle, but very quickly rises to a couple of hundred kilometers per second, very, very near to the center of the galaxy, in exactly the way that that James mentions, that we can measure the mass of a black hole by the rotation of the stars around it. So it's very high at first, but then you expect it to peak fairly close to the galactic center and then start falling off in a smooth way that actually never quite gets to 0. So you expect the rotation to be near the middle, it's very high, and then falling away gradually. What astronomers found, though, when they made real measurements, and this goes back to the work of Ken Freeman here in Australia, and Vera Rubin in the USA, other notable scientists too, they're perhaps the best known names associated with this. What they found when they looked at real galaxies, and they were doing it with, certainly Vera, I think, was looking at the radio signals coming from clouds of gas going round, which behave in the same way. They're just traces of what all the mass in the galaxy is doing. But the bottom line is you find, yes, it's 0 in the middle, goes up pretty steeply in the middle, and then starts flattening off, but it never comes back down again. And so the picture you've got is of a curve, a rotation curve, that starts off very steeply increasing, and then around about the same place where it would have turned over had there been no mass in the galaxy, it starts to turn over, but it never gets horizontal. It basically just continues gradually increasing out to the most distant limits we can see. So it's not a sudden change. It's not, where do we need to think about dark matter? That's a good question to ask. But actually, it's the whole shape of the rotation curve that tells you that the only way you can have this kind of rotation curve is if the galaxy itself is immersed in a blob of something massive, and that's the dark matter. That's why we infer it. So it's the whole galaxy itself that's telling you that, not just one bit of it. Great question, though.
Yeah, fantastic. I drew a graph, Fred.
Good.
Am I close?
Is that
good?
I used to know a mountain that looked just like that in Lancashire, but yes, it is. It's close. It's close to it. It's what it should look.
That proves that you actually explained it quite well. If I can take what you said and turn it into a little picture on a piece of paper and be right, gee, I must have missed my calling at school. Too many paper planes. That's the problem.
Yeah. Should have drawn on them instead of flying them.
I did do that, but I got in trouble for that too. The messages were not very positive.
We might not go there.
No, we won't. James, thank you for your question. Thank you for getting in touch with us from Maine. We appreciate it, and we do love your questions and your messages. Sometimes people just send us photos. Sometimes they just send us a note to say hi. And we love all that, so keep them coming in. And Fred, thank you. It's been a blockbuster episode with the first photo of a black hole and the confirmation of methane spikes on Mars. So we've had a pretty big day.
Absolutely.
I'm ready to go to sleep, really, to be honest.
Oh, sleep well, Andrew. Sleep well. I hope you get over your jet lag.
Yes, you too, having stayed up right through the night to get all this news. So we appreciate it. And thank you as always. It's great fun.
Yeah, and it's just wonderful to see all these new discoveries coming out. I'm just thrilled to be able to talk about it, Andrew.
Fantastic.
So we'll see you next time.
We will. Fred Watson, astronomer at large, and from me, Andrew Dunkley, thank you for your company, and we will be back with you again next week.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.
Holidays start here at Baker's with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
Choose from a great selection of digital coupons and use them up to 5 times in one transaction. Check our app for details. Baker's, fresh for everyone.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.